Hey guys, welcome back to another Default Cube cgmatter tutorial, and today we are doing a very cool project that I'm actually pretty excited about. It's inspired by this Reddit post made by King Syrian, so thank you for the tutorial idea. And what it is there's this cloth, or apparently particle simulation, I don't know what's going on here, and within this you kind of have this pulsing ring that's emissive, and no matter how much the cloth bends, it still kind of passes through it. So that's what we're going to talk about. Again, I have no idea why there's a particle simulation here. We're going to do it in a much more efficient and smart and procedural way than this, so sorry, King Syrian. But there are some interesting ideas here, like for example, with this LED ring, you see there are some smudges where there isn't any emission, and you have this kind of slow-mo cloth thing going on, and we're going to talk about how to do all that in probably a more efficient manner. And I did just try to record this tutorial and messed up, so if I lose my voice in the middle of this or if my voice cracks, just excuse me. I'm just very excited about this. So here is the version I made, and it's pretty much like a rough version, but it has all the principles you need. So you can see I made a basic cloth simulation, kind of the slow-mo, low gravity kind of thing. And if we go to rendered mode, you're going to see we have our emissive rings. And the way I've set this up, we're going to have a ton of control over this. But just to kind of view this, you can see that it has these smudges that the other one had. And let me go to GPU. I don't know why I wasn't already on GPU. It's going to be faster. So it has these smudges that we're going to have control over. Clearly, we have control over the ring. And then also, you notice that this cloth has these tiny circles in it as if it's made out of like particles in the same way. But we're not going to need to waste our time simulating particles. We're going to do it more efficiently. And just to show you, other than the simulation, what's going on under the hood, we have this node network that controls everything. And don't worry if you see this and you're like, I have no idea what's going on. I will show you. I will hold your hand through it. But more importantly, the reason we use this node network is because it gives us a bunch of control. So for example, this slider right here gives us the thickness of the ring. So that's already something pretty cool. We can control the smudges over here using this one, I think. Yeah. We can, of course, control stuff like the color. So instead of blue, you could have it be green or orange or whatever. And then, of course, we can finally control the particles, which is this one, I believe. So if we make this smaller, you can see now there's bigger circles and now smaller circles. So I will show you and explain how all this works. So let's start off with a new project and get started. So assuming that your Blender looks like mine and you haven't messed with the default scene, this is what you're going to see. So what we're going to do is we're going to take this cube, get rid of it, and replace it with a plane. And that is because the first order of business is making our cloth simulation. And you could use any shape you want for this. I just think that a plane makes the most sense for making a nice cloth. And since we're doing some simulation, you need a bunch of geometry. You need a bunch of vertices to interact before we do any simulating. So to do that, edit mode, subdivide. You could do any number of subdivisions, although the less you do, the faster it simulates, but kind of the lower quality it is. So if you kind of want to go between high quality but not taking forever, I recommend 35 if you have a computer like mine. If we click play, nothing's going to happen because we subdivided it, but it's not cloth, so you shouldn't expect anything to happen. So what we're going to do is we're going to go to the physics tab. I already feel my voice leaving me. I don't know how I'm going to make it through it. We're going to make it cloth. So now when we click play, what's going to happen? It's just going to fall. Why? Because it's just cloth with gravity and nothing to interact with, so it just falls. And our goal is to now make this look like that slow-mo artistic thing that King Syrian did. To do that, I'm going to go to the field weights at the bottom here and take gravity and bring it down to 0. So now gravity has 0 influence on our simulation, which means when we click play, nothing's going to happen, because before all we really had was the gravity bringing it down, but now we said the influence of the gravity is 0. So it's just there. So what are we going to replace it with instead? What I like to do is Shift-A, force field, and then turbulence. And when we click play, it's technically adding a bit of turbulence, but it's too small to really see what's going on. So with our force field selected, what we can do is just take the strength and just bring it up a bunch. And you can see the higher it is, the more disturbance it has, and the more our cloth ends up moving. So I'm going to pick something like 600 maybe. Let's see. And you can always change this around. Everything about this is, procedural, and you can go back and fix things, especially when we get to the shading. but nothing is baked in. So I think 600 looks pretty cool, but we can always change it later. So once you're happy with your strength, I'm just going to, pick the cloth, right click, shade smooth, so it doesn't look facetted. And then finally, you may be thinking, oh, I want more subdivisions, but it takes forever, right? This cloth kind of looks too low res. There's a trick that involves not doing more simulating, and that is if you go to the modifiers, you can kind of think of this cloth simulation as just a modifier on the plane, which means we can add modifiers after this to kind of affect the mesh as it is right now. And what we want to do is either add a smooth, which is over here, or a subsurf, and I'm going to add a subsurf. And notice that this makes our cloth look a bunch. It looks better, but it still simulates pretty fast, right? So it's doing our simulation, and then it's calculating what it's going to look like with subsurf. But yeah, I guess that's it, right? You can always change different properties of your cloth. You can change the tension or whatever, but that's just the basics. And I kind of like the way it looks right now. So the rest of this tutorial is the shading, which is kind of the harder part. So let's get to it. So first order of business before we make it glow and look like cloth is we just need rings. We just need rings expanding, and then more come out at every set interval of time. And there are a bunch of ways to do this. I'll show you maybe the common approach and then what we're going to do. But yeah, just make a material. We're going to call it something like cloth emission or something. And let's also save our project to a second attempt for this tutorial. So kind of the common way that you might see people make rings, and I don't really like this method, is you can add a gradient texture. Connect this to the surface. By the way, if you're seeing me do this kind of stuff and you're like, how is he doing that? Go to Edit, Preferences, Add-ons, type in Node Wrangler. And if you don't have Node Wrangler, enable it. It's the best Blender add-on that comes shipped with it. So gradient texture, plug it in, and then I'm going to set this to quadratic sphere. Control T once you have Node Wrangler to add these nodes, and we're going to set this to object. And you can see this already gives us a circle, and then it's really just a matter of creating a second circle, subtracting it to give us a torus. And I'll just quickly show you that. So you just duplicate, make one here. We are going to add some math and subtract these from each other. And then finally, right now we're just subtracting something from itself. So the last thing we need to do is just modify the second one with a color ramp or anything really. And you just kind of do something like that. And you can see how that kind of gives us a ring. Of course, if we do a different kind of fall off type, it's going to be more obvious, although now I need to figure out, there you go. Now you have a ring, but I really do not recommend this method, especially if we want to control the rate of the pulsing and all this. It just gets a bit too complicated. So what we're going to do is just have texture coordinates. And here's where the hand holding begins. We're going to start off by taking our object coordinates and plugging it in. Fine, we just have object coordinates, x-axis, y-axis. I'm not going to explain necessarily what's happening here, but I'll explain the steps in between. What we want to do is pretty much program in, using nodes, the equation for a circle. The same way we made circles before, using gradient textures, we're now going to do it mathematically. And the equation for a circle, if you don't remember text editor, it goes something like x squared plus y squared is equal to radius squared. And that's basically saying we have our x coordinates, our y coordinates, and then do radius of the radius of our circle, and this is going to determine uniquely that circle. Alternatively, you could just take a square root. Take a square root of both sides of the equation. So x squared, y squared. So square root of everything is going to be equal to r. That's another way to write the same equation. And really, all we're going to do is write this equation, the second one. We're going to write it using nodes. And you may be thinking, oh, how do we do that? Well, let me show you. So what we're going to do is we're going to take our object coordinates and separate them. So separate x, y, z. And this is going to give us the x's and the y's we need. So now we have access to those. The next thing we need to do is square x and square y and then add them. So we're going to do exactly that. So add a math node. We're going to set this to power, which you can look for. 2.82 added a bunch of stuff with the math node, which is going to be helpful in this case, but it's hard to find what you want. So I think you can just type in p for power and type in 2. So we've taken x to the power of 2, that's x squared. Duplicate this. Now we're going to do y squared. So x squared and then y squared. Now we need to add them. Pretty intuitive. So just set this one to add. So we have x squared plus y squared. And then what's next? You tell me. It's a square root, right? And we're going to be done with this soon, I swear. So just add that. We're going to change this to square root. And then that means that all our nodes over here, x squared plus y squared and square root of all that gives us the radius just by the equation. So now what we want to do is kind of view this in a way that actually gives us a circle. But we could either do that for two circles, like one circle here, and then use those to make a torus like we did last time. Or, since we're in 2.82, I'm going to show you a trick that lets us do all of this with a single node with a bunch of control. So what we're going to do is we're going to add in another math node. This is the last one for this chain, I swear. And what we're going to do is we're going to use one of these new ones, which is compare. This isn't in 2.81. You got to be in 2.82 or above. And what compare does is it's going to give us three inputs, A, B, and C, and it's going to check A is equal to B with tolerance C, as it says in our tooltip. So here we go. We have three inputs. So we have our first input. Then our second input is what we're comparing it to. So let's say we want our radius to be 1. So right now we're taking our radius calculation and then comparing it to a radius of 1. And then we need some threshold. How close are they to each other? Well, 0 is kind of way too strict. So if we make this a bit bigger, you can see we're checking if these two radiuses are the same with the thickness of this tolerance. And you're thinking, okay, fine. What's the point of all this? The point is that this slider controls the expansion of our torus, and this slider controls the thickness of it, which is exactly what we want. So now the question is, okay, we have a torus. It even animates with the cloth. You see it actually deforms with it. So now the question is, how do we get it to pulse and, repeat over and over and over again without animating it by hand? And to do this, we're going to need our timeline, if I can actually open it. And the normal way you do it is, you'd add a keyframe here, go to a future frame, increase this so it actually expands, add a keyframe, and then we play this. And you can see that's fine, it's animated, but of course it has the issue of once it's done, we need to kind of go back with the keyframes and repeat it over and over and over again. And this is fine, right? Like you could do that. You could just copy, paste, and then we have, let me play that. We have this thing that then resets over and over again. It looks pretty janky, but whatever. This is one way to do it. But of course, we want to use that word procedural and drivers and do this kind of the smart mathematical way. So what we're going to do is I'm going to go back to the first frame and just kind of set our numbers the way we want them to. So I'm going to have a thickness of 0.1, let's say. What we're going to do is we're going to add in a value node, connect this to the expansion rate, which again is what we're comparing to. So this is going to control that. And then we're going to use drivers. So right click on the frame number. This is just what frame we're on. So we just right click, copy as new driver, paste as driver, which means whatever number is in here, it's going to reference this and put it exactly in this purple socket. So as we go, you see it's going 7, 8, 9, 10, 11, 12, etc. And really, on frame 1, we're going to have a radius of 1. On frame 2, we're going to have a radius of 2, etc. Of course, that's not really what we want because then the radius gets too big outside the bounds of our cloth, but it is a start. So what we need to do is just take these and kind of make them smaller so it doesn't get so crazy so fast. Okay, so how do we do that? Well, there's a bunch of ways, but what I would recommend is we're going to take one of these math nodes and just put it in this chain, and we're going to divide, so D to quickly choose divide, by some number, let's say 10. So now instead of going, 0, 1, 2, 3, 4, 5, etc., it's going to go 0, 0.1, 0.2, 0.3, 0.4, 0.5, because we're dividing these by 10. Which means, actually I'm going to start this at 0 instead of frame 1. So we're starting at 0. You can see now it's going much slower. It takes many more frames to reach the edges of the cloth, so if we play this, kind of looks nicer. Of course, if we make this number bigger, like 20, twice as big, it's going to go twice as slow. If we make it half as big, it's going to go twice as fast. So this right here controls our speed of expansion. That's the way you want to think about it. So you just kind of want to pick a number you like, so maybe 20 if you like a nice slow pulsing. And now the question is, okay, we did this, but it doesn't repeat, right? This number is just going to keep increasing even if we divide it, and it's eventually going to reach the bounds of our cloth. So what we need to do is take this number and have it cycle back to 0. That's the trick. And if you think about it, if you think about a clock, you're reading the time, you have a clock, it goes 1, 2, 3, 4, 5 until we get to 12, and then it just repeats. So in some sense, you'd think that you'd go to 13, but it just goes back to 1, and that's exactly what we're going to be doing here, and that is called modular arithmetic, if you've never heard of it before. What that means is you take another math node, so I'm just going to duplicate. You're going to set this one to modulo for modular arithmetic, and that is over here. Hard to find anything. And then modulo is basically going to look at our number, being our frame number, and then once it reaches a certain threshold, like 20, it's then going to roll back over to 0. So if we do something like 20, let's see what that looks like. You can see it's repeating, and it's pretty good, although it's not reaching the edges of the cloth, but that is the idea. So if we make this number bigger, what do you expect to happen? Well, it's going to have more time until it needs to repeat, so you see now there's a bigger gap in time before our pulsing. We can make that even bigger, 35. I want there to be some time where this reaches the edges and then there's nothing, and then there's a new pulse. And I really like the look of that. Okay, cool. So now we have this number right here. That's our time between pulses. We have this one, which is our speed of expansion. We have this one, which is our radius, or our thickness, really, is the way you want to think about it, like that. So instead of having this, we could have it be half as thick. If you want very thin rings, although I do like what I picked before, 0.1, pretty good number. But yeah, that is the very basics of setting up just our rings pulsing that deform with the cloth and everything. So let's save again. So now the question is, we have our very basics of what we need. How do we make this look like, porous cloth with the emission and everything? And at this point, we are going to switch over to cycles, because now we care about what this looks like. Cycles, GPU, rendered mode. And hopefully you understood everything so far. This is probably the hardest part of the whole tutorial, just understanding what's going on here. Again, we just took our coordinates, did a bit of a calculation for the radius using this equation, x squared, y squared, addition, square root. We then compared it to some desired radius, which we are changing over time using everything we talked about with the threshold of the thickness, right? That's everything we did. So now, how do we make this look good? So what we need to do is add in two, not materials, but two BSDFs, one for the cloth and one for the LED glowing of the ring. So we're going to add in a mix shader. And we want all of this like black and white image that we made, essentially. We want this to be the factor. So really all we've done here is we made this thing using a bunch of math, and this is just going to decide where it's white, we want there to be glowing, and where we want there to be black, and where it's black, we want there to be cloth, right, without glowing. So we're going to use this as the factor and view that. And then we need to add in two BSDFs. So let's add in a emission for the glowing part, and I think that's going to be the bottom. See? Yeah, you can see we're changing the color and it works. And then for the second one, you have a couple options. You can use a translucent BSDF or a principled BSDF. I think translucent's probably the way to go, but I'm just going to start off with a principled, and then we can change it later, of course. And the nice thing about this is we can pick our emission color. So King Syrian had a bluish thing going on, but it's much stronger, the emission, so you can make that stronger, and then it's going to glow more. And then you can see it's glowing, and there's definitely some light fall off. But the reason we're not seeing it that much is because the world also has a lot of light in the environment, so you can go to the world tab and just bring that down a bit. So it's glowing more. And then also, there might be a whole thing with the normals. So let's see. I haven't actually tested this before. If we select all of these in edit mode and then do a flip normals, I wonder if that changes anything. I guess not. I guess the reason it looks so bright here and not over here is because we have a light above it. So we have a light. It's kind of hard to see. I don't know where it is actually. Oh, it's up there. Delete it. There we go. Now we have a very nice kind of blue cast going on the top and bottom. Sorry, took me a second to figure that out. But yeah, if you have a light in your scene, that is going to affect it. And again, everything we do here works over time because that's how we set it up. Okay, cool. So now we have our emission. For our cloth, maybe we want something a bit cooler, so maybe a blacker cloth, so it doesn't have that much visible against this black environment. And then we could also, I mean, cloth isn't metallic, but you could make it metallic. Roughness is going to change how this interacts. So here we have a very kind of glassy cloth. I don't think we're going to change much of this, but this is definitely a good start. Okay, so now what kinds of things do we want to add? Well, first of all, we said that we wanted to add that splotchiness, so it's not just a perfect LED ring that's uninterrupted. And to do that, what we're going to do is we're going to add in a Musgrave. And by the way, the Musgrave looks like this. So this is going to be our splotches. We can control how many splotches there are and what they look like, etc. Okay, cool. So now to have these interact, all we have to do is add in another math node. And I'm going to set this one to multiply, which is kind of like a AND operation, if you know what that is. So we just connect these two to the multiply. And now you can see it's actually affecting where our emission shows up. By the way, the reason it's multiply and not anything else is this is essentially a black and white image. Where it's white, we are multiplying by 1, which means just, keep it, which means that's where the LED is showing up. And then 0, it's going to multiply by 0, which turns it to 0. Basically, all you need to know is that using multiply is going to let these interact together. So we can always change the scale or the dimension. And you just want to play with this until you get what you like. I think the detail, increasing that, gives it a nice grungy look. And then the scale is just going to affect how many splotches we want in general. So already that looks much cooler. Okay, I think probably the next thing we want to do is make it kind of like half transparent, where we want those like little particles without actually doing the particle simulation. And to do that, all we need to do is we've done everything here, and now we're going to add in another mix shader, and this time we're going to mix it with a transparent or a translucent, whatever you want, BSDF. And right now it's like mixing them, 50-50, so it's kind of like half transparent, and we can make it fully what it was before or fully transparent. But, of course, we want some kind of mixing factor, and for that, we're going to use a Voronoi texture. And you may be thinking, Voronoi, why that? And I'll show you. What we're going to do is we're going to take this scale, bring it up, and then we're going to take our randomness and bring it down. And you can see that effectively makes a grid. I'm not going to explain why, it's a whole thing, and I've explained it in other tutorials, but this is one of the benefits of Voronoi. It makes this nice grid, and if we add a color ramp before we view it, we can actually control what this fall off looks like. So we can bring this up, bring this down, and we've kind of generated the particles, maybe the inverted versions, but we've generated those, so we can use that as the factor. If I can connect these. And it's kind of hard to tell what's going on right now, so if we take the scale, which is kind of like how many particles we have on the X and Y axis, and boost that up to something like 50, we can now see what's going on a bit more. And you can see that it's kind of, I don't know if it's showing up on YouTube, but you can see there's areas where it's very opaque and very transparent. And again, we might want to affect those a bit more by maybe doing constant fall off, which let me show you what that looks like. That's going to have much harsher edges. So it doesn't have any, fading. It's just very, very harsh. So let's see what that looks like. Yeah, there you go. Now it's looking a lot more cloth-like. But then, of course, we want very, very small fibers. So take that scale, make it much bigger. Something like that. And, of course, everything we've done, including this ring, including the grunge, including these little particles, they all deform with the cloth no matter what simulation we do. So we can always change the simulation, right? It doesn't have to be this low gravity thing. And then, of course, this is kind of like the basic thing I showed you in the beginning. We can always modify this. So, like I said, instead of principled, you can play around with something like a translucent. So maybe change that over here. But then, of course, you want to copy the color of the cloth over as well. And that might look better. It's just kind of like your opinion, I guess. It's a sci-fi thing. It doesn't actually exist. So it's really up to you. We could also, like I said, replace this with the transparent to give it a bit of a different vibe. This is going to make it look like there's much more glowing going on, which maybe that's what you want, or maybe you do want the transparent. I think in this case, that's definitely what we want, the translucent. And you can see if we zoom in, it's still kind of semi-transparent, or I guess the word is translucent, where our Voronoi texture allows it. And then, just to remind you, we can always change the color of this, which is a cool feature. But I think I want to exit this tutorial with one final thing, because that's the basic effect. And that is, like I said, we can always change the cloth simulation, and I want to play around with that idea. So we're going to delete our turbulence. So right now it's just going to stay still. Actually, it's not, because the simulation was baked in, I guess. So we're going to need to go to cache and then overwrite it, or delete all bakes. I always forget how this works. You bake it, and now it's probably going to have nothing once it's done baking. Yeah, now it has nothing. So what we need to do is I want to have it have gravity this time, and we're going to have it kind of collide against a cube, which I'm going to put kind of to the corner here, make this a collision object, and then I think we just need to bake again, and that should work. So delete bake, bake, and once it's done, it's going to fall and hopefully slide off the cube or something. We'll see. Simulation's not my forte. Yeah, you can see that's kind of what happened. So it fell and it's sliding off, but we don't care about that. What we care about is what it looks like here. So we have this nice like ring thing, and it's lighting up the cube as it falls and all that. And that's really cool. And basically, most of this was just making the material. So you can always take this material and apply it to anything, right? It doesn't have to be the cloth. You can take the cube, apply it here, although it's going to look a bit strange, I believe. Nope, this one. It's going to look a bit strange because it's not using Z coordinates, so it's really just going to do that. So maybe you want to use something like UV coordinates. But yeah, that's just a cool material. It kind of reminds me of the Spider-Man sequence where he's like tripping out or whatever. But yeah, hopefully you enjoyed this tutorial. I'm sorry that I lost my voice during it. But if you did find this tutorial useful, the best way to help me out is via the Patreon. Subscriptions, likes, comments, all this, they're moderately helpful. But if you really want to donate and everything, Patreon is the way to do that. Of course, it's somewhat a donation. You're getting benefits like Discord access. You're getting benefits like early access, some private tutorials. There aren't many, but there are a couple. But yeah, just generally, if you want to keep these tutorials free and everything, that is the way to do it. And thank you guys so much for watching this free tutorial. I hope you learned a lot. And again, thank you to King, what was it? I'm opening it up. King Syrian for the idea. I'm sorry that your thing didn't live up to what we made. I don't know, it looks cool. Whatever. Thanks for watching.